Welcome to another Web3/blockchain project that we're going to be building using Infura. This project is going to be a lottery dApp. Now, there are gaming companies out there like crypto games using something similar. The point of this is you have multiple users enter, each of who pays in Ethereum a certain amount in the pot. And at the end, you pick a winner and you randomly select a winner, and that winner takes the entire pot. But we're just gonna have fun with it and learn Web3 by building this lottery dApp. Now, let's go ahead and kind of demo what the app looks like. So here's the app. I currently have no players inside here, right? You can see that I have 0 players at the bottom. So I'm going to go ahead and with one of my accounts, I'm going to enter this, okay? And then we're gonna add in one person, okay? And so I'm going to log in here, cool. And now we have one person and I'm gonna enter with that account, cool. So let's go ahead and do that. I'm gonna enter, boom, I'm in. And now let's go ahead. We're gonna speed up through this process so we can go faster. I'll just pay higher gas fee. Now I have entered as a user and you can see at the bottom that I'm inside. Now I'm going to enter with a second account. So let's go ahead, repeat the same exact process and we'll enter it. All right, now we're gonna enter a second user. So I'm gonna go ahead to my Metamask. I'm gonna speed up and do the same thing, and boom, at the bottom, you can see that the second user has been added to this lottery, and each of them added 0.015 ETH to the lottery. And at the end of this, what you'll notice is we have a winner, and that winner, which is this account right over here, he won all of that ETH, okay? So that's how this will work. Next up, what we need to do is we need to sign up for Infura. And the reason why we need to do that is so we can actually build this app. It's going to be completely free and it's going to allow you to build your Web3 app and scale it as much as you want. So I want you to go to the URL in the description below. Okay, we've given it to you. You'll get to this landing page of Infura and then just hit sign up at the top. Once you do that, just make sure you create an account under get started for free, pop in your email and your password. And once you're done doing that, it's going to ask you to verify it. Then just simply go ahead, verify your account, and then it'll take you to this next page. Okay, pick your role, etc., which organization. You can pretty much pick whatever you want, hit submit. For the network, we're going to choose the Web3 API, formerly Ethereum, and for name, we're going to say production and then just hit submit. Okay, once you're done with that, it's going to bring you to this page. At this point, this is where you are. You can take a look around, but your job here is done. You don't really need to do anything else. With that said, we're going to continue and next up, work on installing Metamask. Now we're going to go ahead and install Metamask. If you already know how to install and use it, just skip this part. Timestamps are below. I'm going to keep going. So go to Metamask on Google, find it as a Chrome extension, hit add to Chrome. And what you want to do after you add it to Chrome is just hit agree with everything. So it takes you to the next part. And this is the important thing that I need you to do. Once you are on this page where it says new to Metamask, do not pick no, I already have a secret recovery phrase. Choose yes, let's get set up. Create a wallet there and then pop in your password. And the important thing we're going to really need is this mnemonic phrase that it gives you, aka your secret recovery phrase. This is the important part because in this app, in this dApp that you're going to be building, you're going to need access to this. So make sure if you already have an existing account, make sure you have the secret recovery phrase. If you don't have a secret recovery phrase or you forgot it, just make a new account right now. Okay, and then follow along that way. It's going to ask you to confirm your secret security phrase, and then it's going to ask you to safely store it somewhere. Then in your account, you're going to notice that you don't have any other accounts, like any other networks. You only have the Ethereum mainnet. So what you want to do in that case is you want to click where it says show/hide test networks and go to your advanced settings. And in there, you want to say show test network. So make sure that's turned on and make sure the show conversion on test networks is also turned on. And now when you hit X and you hit your networks, you can see that all these other test networks are there like Ropsten and Gorley, etc. All right, so type in Ropsten faucet because what we want to do is we want to get some free Ropsten, which is essentially Ether, okay? And that's how you're going to be able to play with this app and do stuff with this app. So go to this Ropsten testnet faucet, go ahead to your MetaMask, and you can pin it just like I did here. Right click and copy the account address and paste this account address and say, give me Robson ETH. It's going to give you the Robson ETH. You could see that we got 10 Robson ETH right here. Now, I do want to highlight something here. You will see Robson will shut down in Q4. Okay. So it's going to be shutting down soon. But what we're showing you here is just as easy to do with the Gwirly test network as you can do with Robson. So you could follow along and you could just do it with Gwirly. Okay. So yeah, so if you're watching this after 2022, just do that. You should be fine. With that said, we're going to keep going. And now we get to the coding part. Now open up your command line and we're just going to go ahead and get your entire project set up. Some key notes that I want to show you is I want you to go ahead and do into your GitHub folder or wherever you store all of your stuff. And then I want you to use npx clever programmer. Now, before I continue, the benefit of doing this way is we are giving you all of the assets for, just giving it away for you. Okay. So you're going to have access to all of the assets. You will have access to the styling of this app. You will have access to the components inside of this app. And, majority of front end, you'll get access to. Okay. What you won't get access to are things like blockchain and smart contract, because in this project, I don't want to focus so much on the front end part. Otherwise, this tutorial would be 9 hours, 10 hours long. We want to focus more on the interesting aspects of this project, which are the smart contract, the blockchain part. So that's what we're going to be focusing on more. And we're giving away a lot of this. And if you do npx clever programmer, you'll automatically get access to all of these things for this project, for this lottery dApp. Okay, so we're making your life a lot easier. So do npx clever programmer at latest, and then it will install it globally. And then just go ahead, pop in your email. And what you want to do after you put in your email is it'll ask you for your name. And then simply go ahead and choose the project. So here, I want you to go ahead and choose the lottery app. Go to that. Okay, select it. And then you're just going to hit enter. Now it's going to initialize your project. It's going to give you the front end, right? It's going to install all of the dependencies. And it's also going to tell you to smash that like button while you wait. So go ahead, do that right now while it's loading. It also automatically, there's a fancy thing that we've added to it where it automatically opens up your Visual Studio Code. If it gives you an error there or doesn't work for you somehow, just go there and open up this folder inside of your Visual Studio Code. And there you go. There's your project, your lottery app. There you go. Okay. This is your starter. Now, all I want you to do is go ahead and do yarn dev. And it should open it up on your right-hand side. Or just open it up in Chrome on your local host, 3000. Okay. And just get to the part where your app is up and running. Okay. So there you go. That is the starter. Okay. If it doesn't error out, it's telling you that, hey, this is working. All the styling is here and everything is here. And this blank page here with this color, that's a good sign. That means your starter is completely working. So good job. And with that said, we're going to go ahead and continue building. All right, now what I want to show you is that at any given time, I don't want you to get stuck, all right? I do not want you to get stuck. So what we have done for you is this thing that you got from npx clever programmer. If you're a more advanced user, you are sitting on a branch right now called CLI starter. And there's a branch of this project that's called, I believe, main, right? The main one. The main branch actually has the solution. So at any given point, you could switch to that branch and get the solution. Okay, this is the branch you're currently on by default because all you did from the CLI tool was clone this repo on your computer. Okay, so let's just walk through it. And you could also go to this repository from the link in the description below. So it has a solution on there. So you could do it that way too. Just use one of the links in the description below. And you could see that we have all of the code right there, right? I could click into context and I can click context.js and it will give you the entire solution for this project. Okay, so there you go. This is just a thing that's made available to you to get answers, to get unstuck at any given point. Just wanted to highlight that. With that said, now we're going to start building the smart contract And this is going to be a really fun process because we're going to do it step by step. So let's go. All right, now what we're going to do, guys, is we're going to go ahead to Remix IDE. All right, so we're going to go to Remix IDE, which is a phenomenal online IDE, and it's completely free for writing smart contracts and iterating and getting live instant feedback for everything that you're doing. So go ahead there, okay, and start coding online. Click that, and it'll bring you to their page. Just hit accept, cool, hit next, blah, 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 and then you should be good to go. Okay, here you're going to choose a workspace name. All right, you could call it lottery. We'll call it lottery DApp. And then on the left-hand side, you will see that it populated it with some dummy contracts and stuff like that, just to kind of get you started. Okay, so close the scripts tab, close the test tab, go into contracts, and inside of contracts, we're going to make a contract, and it's going to be called lottery.sol. Okay, so lottery.solidity contract. Great. Now that we're doing this, let's go ahead on the left-hand side, and I'm going to click on that third tab, and we're going to choose auto compile. And for the version, we're going to choose 0.8.15 plus. That's the version. Let's go back to our lottery.sol. And here, first of all, the first thing we do always is pick the license. So we're just going to choose the MIT license for this one. We're going to pick our Solidity version at 0.8.15. We're going to create a contract called lottery. And in this contract, okay, the first things that we're going to create are state and some storage variables that are going to be necessary for us. So let's create a owner. We're going to need to keep track of our owner. Let's create also a players array. Okay. That's where all of our players are going to go inside of. Let's also go ahead and create a winners array. And then we're going to go ahead and create a lottery ID, which we will keep track of. Okay. And now I'm going to go ahead and explain something special for you. Okay. So for example, I told you that these are the variable names here, right? But I didn't explain to you what address public, address payable public is. So let's go ahead and do that now. Address is a special data type in Solidity, which refers to, anytime you see a wallet address that's like that, there's a specific data type for that. That's not just a string. Okay, in JavaScript, you'd store that as a string, but in Solidity, you store that as an actual data type. Public here means everybody will have access to these variables, meaning that even outside of the smart contract, you could access them. Okay, so that's why it's public, 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 public. So you could make it private as well, which would mean that we can't access it from outside. But in this case, we don't need to do that. Okay, so that's the word public. Okay, so hopefully that handles that situation. Now, what is this thing called payable? Payable means that these contract addresses are put in a way where we can pay them or we can send money to them. All right, now payable means these are the guys that are, where we can actually send them money. Okay, so that's why this address type is a payable type, because any of these players, we want to be able to send them money based on if they won the lottery or not. Okay, that's what's happening there. This empty open close array that you see over here, that basically says that this data type is going to be an array of addresses, meaning that there are going to be multiple addresses in here. So players variable isn't just going to be like one random 0x ... address. It means it's going to be an array of addresses. So it's going to look more like this, comma 0x ... comma 0x ... 0x ... I think you get the idea, right? With multiple addresses there. Okay. So that's what's happening inside of this array. It's going to be an array of addresses. Then we have array of winners. The reason why we're not making this public, or sorry, not making this payable is because they've already won. So we don't want to be able to pay them programmatically or at all because they've already gotten the money. And then we have lottery ID, which is an integer because it's going to be 0 when, it's the first lottery. Then it's going to be 1 on the second lottery, 2 on the third lottery, etc. And we'll show you how to do that as well. Okay. All right, let's keep going with this. So once I'm done with that, we're going to create a constructor. And this constructor, this runs when the contract is deployed. Okay, so let's create a constructor here. We're going to go ahead and say owner is the message sender, aka whoever created the contract. Whoever was like logged into their Metamask and was the person that created the contract at the time that the contract was created, okay? That's gonna be set as the owner. So what constructor means that this piece of code is going to run right when this contract is deployed. So the very first time this contract is deployed, it'll run, and then this part will never really run ever again. It'll only run once when the contract is deployed. If you have experience with React, think of it kind of like your use, your use effect hook, where it fires off once the page loads, and then if you don't have any dependencies, it doesn't fire off again, right? Kind of like that, except it just runs once forever, even if you refresh the page. And we're going to set the lottery ID to 0 because that's what we want to initialize it to be. Next up, we're going to create the enter function. So this will be the function that allows a user to really enter the lottery. So let's go ahead, say function enter, and I'm going to say it's a public function. Okay. And I'll explain why we're saying payable afterwards. This function, we want to make sure that we require the message value is you need to put in, basically what we're saying here is, hey, you need to put in more than 0.1 ETH. Okay. So if you're gonna put some money in the pool, make sure it's more than 0.1 Ether. Because you can't just put like baby money in it, right? We're here to play. The big boys are here. The big boys and the big girls are here. I don't want to get canceled like Andrew Tate. So here, then once we do that, we want to do players.push, and we want to push the address of whoever was like the logged in user in MetaMask. Whenever you see message.sender, think the current logged in user with MetaMask. Okay, that's the easy way I think about it. And so I'm pushing whoever was currently logged in and entered the lottery. Boom, add them to the players array. That's what we're doing. All right, so now what's special about this function and why we're calling payable right here is because this function, by doing payable here, means you can actually kind of quote unquote pay this function, okay? When you call this function, you could enter and you could literally pass it like 2 ETH. So think of it like that. You're almost calling the function. You can pass it a certain amount of ETH. And that ETH that you pass this function, it will actually store that inside of the contract address. Okay, so the contract address. So think of the contract address like just another wallet, just like kind of how you have a wallet. Contract address kind of has a built-in wallet. And so the money is going into the contract pool. Okay, so that's how the money is going into the pool. And then we just make sure that the message value, right, is greater than 0.1 Ether. And then if it is, we go great. We add that to our players array that we created up at the top. And we want to make sure it's payable so that whoever entered the players array is a payable address. Okay, so that way we can pay them out later. One thing to note here is if you didn't have the word payable here, you wouldn't be able to require message.value. Okay. All right. So that is the, the heart of that enter function. Now let's go ahead and test it out. So by the way, here's the really cool thing about Remix, right? Look at that. It just gives us so many accounts and all of them have 100 Ether in it. So you don't have to go to a faucet, get Ether in your wallet, do all this garbage. You just have it here right away, ready to go. So that makes our lives very easy. Okay, let's go ahead and I'm gonna take this account, the 0x5b3 account. And with that account, I'm going to go ahead and deploy this smart contract. So let's go ahead and hit deploy. Now you'll notice that when it deployed, it took some amount of Ether out of my account to be able to deploy. Okay. Now the smart contract is deployed. Now we have this function enter, and we'll try to run this function enter. I just tried to run it. Do you notice what just happened? Right when I tried to run it, I got into this error over here. And this error basically saying, hey, you don't have more than 0.1 Ether. Okay, so we need to actually send it some money before we can run it. So we got this error and we're not very happy, right? Because you don't like when you get errors. But this happened because we're not giving it more than 0.1 Ether, equal to or more than. So what I'm going to do here is I'm going to go grab value. And sometimes this is a little buggy in Remix IDE. So just Command A, like select it and then hit delete backspace. And then you can like hit 1 or something, or hit the arrow at the top and then it'll actually increment the value. So sometimes this bugs out. Make sure you get the 1 there and then change it to Ether once you're done doing that. And now go down and hit enter and let's see what happens. And boom, look at that. We were entered into the lottery. So let me ask you a question. If I pooled 1 ETH and I entered into the lottery, what's the total lottery pool right now? I'll give you 5 seconds to try to answer this. 5, 4, 3, 2, 1. I really hope you said 1. Okay, I really hope you did. Because it's 1 person and 1 person entered with 1 ETH. So we have 1 total pool. Okay, great. I'll ask you this question again when another person enters. So keep your answer ready. I'm going to go ahead and choose a different account. So I'm going to choose the 0xAB8 account with 100 Ether because I'm a big boy. We're going to scroll down and I'm going to hit enter. And let's see what happens. I got an error because I didn't add any value. I didn't pool any money. So let's go ahead and pool it. I'm going to go 1 and then let's click enter. There we go. We just entered it with 1 ETH. Okay. So now the total amount of the pool is 2 ETH. Okay. Now let's go ahead and grab all the players that are currently entered so we can see their wallet addresses. All right, so for get players, I'm going to write this function. It's going to be called, surprise, surprise, get players. And it's going to be just a public view, meaning it doesn't really do anything. It just shows stuff. What we're going to be returning here is an array of payable addresses. And just write memory because otherwise you're going to get an error. And at the bottom, I want to say return players. Okay, so we're going to return players. That's all it does. Those are the players that we're going to be returning that we initialized, at the top. Okay, great. So now that this function is made, let's go ahead and kind of re-enter. So we're going to delete the smart contract that we previously had because we're going to need to redeploy this new smart contract because we just made changes to it. So I'm going to choose my 0x5b wallet to deploy it with. We just deployed the smart contract. It is deployed. Let's click it so it expands. And here I have my get players function, as you can see. I have an array of addresses that is currently empty, and it's a 0 because there are no players in the pool right now, right? Now I'm going to go ahead and enter with 1 ETH with my, the owner. The owner is going to come in and enter. It's like the dude who owned the basketball team, right? Jumps down and starts playing with Steph Curry, and their team members. So that's what's happening here. The guy who created the lottery is playing the lottery. A little conflict of interest there, but it's fine. Now I'm going to choose a second address and hit enter, okay, with the 1 ETH. Now we got 2 players. Okay, let's see who, and yeah, when I hit players, right, boom, we could see the 2 players are showing up. So this function, get players, is working perfectly. That is amazing. Now we're going to write a new function called get balance, and it will get the balance of the pool, aka the balance of the contract address. So if it has 2 ETH, it needs to show 2 ETH. So what we're going to say is return address this.balance. Why am I writing the keyword this? This refers to this specific contract address. It refers to this contract, the one you're writing. Okay, so it'll return the balance that this contract has. That's how we get it. Now let's delete our contract. Let's go back to our 0x5b account, which won't be called 0x5b on yours because it'll probably be something different, right? We all get different addresses with different, with 100 ETH in it. Let's go and hit deploy again. So you can see you have a bunch of you have your deployed contract, and now you could see the get balance, which I saw nicely hovered over for you. Then we're going to, then we're going to put in 1 ETH into the pool. Let's hit enter. So I joined with 1 ETH. So the owner jumped in again with 1 ETH. And let's go and see what happens when this other guy jumps in with 1 ETH. Let's hit enter. So now 2 people have jumped in with 1 ETH. Let me ask you a question. Currently, what's the pool size? How much ETH is in there? I'll give you 5 seconds. 5, 4, 3, 2, 1. I hope that you said 2 ETH because 1 plus 1 is 2. Okay. If you didn't get that right, you, my friend, have much bigger problems than learning blockchain. Okay. So I would be really worried if you didn't get that answer right. You look yourself in the mirror and, oh yeah, okay. So it's showing that we have 2 ETH, but it's showing like 2 trillion or 2 billion ETH. And the reason why it's doing that most likely is because it's showing that in way. Okay. Yeah. So way is like a very small unit, right? Way is like think of way as you have cents. Think of ETH as dollars. So you have dollars and then you have cents, but something even smaller than a cent. Because just to expand on this analogy, right? $1 is 100 cents. So 1 ETH might be 100 way, even though 1 ETH is way bigger than 100 way. It's way bigger. There you go. And now I'm writing a comment for you, letting you know that Solidity works in way. So it's written out and extremely obvious to you. So you just have no chance of missing that piece of information. Now we're going to get lottery ID. And I'm going to create this function. It will be called get lottery ID. And this will be a very simple function. So it's going to be public view returns, and we're going to return an integer. And we're going to, if you see uint, it just means an unsigned integer. And that means it could be negative or positive. But literally, whenever I say int, just think uint. Keep your life easy. And then we're going to go ahead and do return lottery ID. So very, very simple because we've made this variable up at the top here on line 9. And we're simply returning it on line 36. So in order to test this get lottery ID, we need to delete our current smart contract. We need to go back, and then we're going to deploy our smart contract. So let's hit deploy. It's been deployed successfully. You can see at the bottom it's there. And now you can click get lottery ID, and it shows you that the current lottery ID is 0, which makes sense because in the constructor, we defined it to be 0, right? Boom, there we go. the hand in the brain. We defined it to be 0. Okay, perfect. Now we'll make a new function, and this will allow us to get a random number. This is going to be a helper function for picking a winner. So I'm going to create this function, and we're going to say get random number. And it's just going to be a public view. It's not going to mutate any data, so it's not going to cost us anything. Okay, and it's going to return an integer. And it's going to return a random number. And what we'll do, so I'm going to get, so CAC is going, 256 is going to help us generate a random number. And to be technically accurate, it's going to be a pseudo random number, which, you know, if a really professional hacker tried to destroy your app or hack your app, they probably could. So if you're building a production, you know, app and you need this random number to be truly random, then you should look into Chainlink and how you could set this up with them. Okay, I wouldn't try to do this yourself using pseudo code. Okay, so we got so we're gonna go ahead and we're gonna take the ABI and we're gonna say in code packed, we're gonna pass it the owner of the smart contract, and then we're gonna give it a block.timestamp. So we're just gonna give it some unique pieces of information like the owner and the timestamp. And we're hoping that that information, when we give it to it, it'll encode it. It'll use the algorithm CAC256 to kind of scramble it. And then we'll call integer on it because and at that point we'll assume it'll give us somewhat of a random looking number with you know, fairly weird obfuscated information that we're giving it. So that's how we create a random number. I wish they just had math.random because this is ridiculous, right? But we're early, so we got to pay the price for being this early. All right, let's go ahead and delete our smart contract that we had deployed. And now we're going to pick a winner. That's what we're going to be doing, okay? But let's go ahead and test our get random number first. So I'm going to deploy our smart contract. Let's go down. And you can see get random number function is right there. Let's click it. Let's see if anything happens. Whoa, something did happen. It gave us this massive random number. I mean, that would have been crazy. Can you imagine if I asked you to guess that number? How screwed you would have been? Holy but Jesus, that is an insane number to guess. So for us, I mean, you know, the pseudo random number is pretty darn good. Okay, CAC is doing something useful. Okay, let's go ahead and write this pick winner function, and I'm going to call it pick winner. It's going to be public. We're going to require that the person who can pick the winner is the owner. Nobody outside of the owner should be allowed to pick the winner. And even the owner will get to pick the winner randomly. So that's what we're doing, require, and we want to say, hey, make sure that the current logged in Metamask user, aka message.sender, you know, or whatever wallet you're using, is the owner of the address. Okay, and I believe we assigned the owner when the constructor happened, right? When we deploy the smart contract. And then we're going to create a random index using the get random number function we made. And then we're going to do module players.length. And here's what's happening here, okay? Let's say you have, you know, you have 5 players or 2 players, Ryu, and you have Ken, okay, from Street Fighter. Get random index, whenever you run this function, it'll either get you 0 or 1 or 0 or 1, okay? Literally just those, out of those 2 numbers, it'll randomly pick between those 2. Now let's say that you had also Zangief. Now this random number will get you a number between 0, 1, and 2 randomly between these, okay? So that part of how, so remember how get random number was giving you this big giant number? Well, you might be thinking, how the heck is that going to give us a index number like 0, 1, or 2? How is it doing that? That is the magic of this modulo players.length operator. Is very nice. And modulo allows us, it's a remainder. Okay, that's what it technically, mathematically speaking, modulo is just a remainder. So if you did 3 divided by 2, you'd get a remainder of 1. But another way to think about it is it just allows you to wrap around whatever you give it. So if you give it like 2 or a number 3, right, then effectively you're taking this giant number, you're dividing it by 3, and you'll have some remainder left over that'll be always between 0, 1, or 2. So that's the trick we're doing here. The way I like to think about it is if I give it 3, it'll always wrap around and give me between 0, 1, and 2. It'll always do that if I give it a module. Like modulo allows me to wrap things around. Okay. Whatever mental framework you want to use to understand that, that's fine. But at a higher level, if we ignore all this nerdy crap, just know that random index gives you between 0, 1, and 2, or whatever the length of that array, players array is. So if that player array is 100 items in there or 100 players in there playing the lottery, then it will be between 0 to 99, and it'll pick a number between, that entire range of 0 through 99. Okay. All right. And then we're going to grab a random player and transfer them the funds of this contract. So remember, address this dot balance. Okay. All right. So there we go. This allows us to take the funds from our contract address. Okay, so let's say that we have this our big pool, right? And it has all of the monies. Then we have this like array of players, right? Player 1, player 2, player 3. We randomly select, let's say this player 3, right? And then because of this here dot transfer, we are able to take that player 3, right? And let's say that they're a real person. They're very happy. Then we send them the funds. Okay, this is what's happening, guys. There's real life stuff happening. You're changing people's lives writing this code. So don't just think of it like random, nerdy math numbers. Somebody will be able to use this one day and get money in the bank account, and then they can provide for their little tiny children who are much smaller than them. This is not to scale. But yeah, because that would be a huge face, right? If your little child that was 6 years old was smaller than your face, that would be crazy. Unless you're Shaquille O'Neal. So now we're gonna go and grab the winners and push the player that was the winner. Okay, so the person that we chose to win, we're going to push that winner onto the array. So, in other words, this part over here, player's random index, okay, this weird looking code, that just really means winner. Okay. And so all we're doing here is we're just pushing that winner. Okay, that's what's happening. Hopefully that's not too scary or weird or freaky. What the heck is this? Okay, whatever. I don't know. Maybe I'll use it one day for something. But for now, let's keep going. All right, now we have lottery ID, and what I want to do is every single time you've picked a winner, well, at that point, essentially the lottery is done. The current lottery is done. So when the current lottery is done, at that point, I think we should increment the lottery ID by 1, because now, you're technically on the second lottery. Because the first lottery is over. People have been paid out, got their money, and life's good. Okay. And last thing we want to do is remember that players array we had like the current active players that were playing the lottery. Well, we need to clear that array. So we're going to write this function that's going to allow us to do that. So imagine you had this array with player 1, comma player 2. What this function is going to allow you to do is really just turn it into an empty array. That's all. Okay. And not function, but we're just going to take our variable players that we had initially written, and we're going to just reassign it and give it a new definition. And we're just going to say, hey, become an empty array. I wish Solidity could just make it easy for you. Okay, what we're really writing here, before I write it and freaks you out, here's what we're really writing. Players equals empty array. That is it. Okay, in JavaScript, that is what you would do, and you would move on. In Solidity, they want you to just go through a lot of pain and be super verbose with what you're doing. But I understand why, to make your code less error prone, add in type safety, increases the speed. I understand, but it's still kind of annoying from a developer experience perspective. And so that's all you're doing here. You're just saying, hey, players should be a new thing, and it should be a array of address payables. And currently it's at size 0, meaning it's just currently empty. We're making it empty. Okay, great. Okay, now let's go ahead and play with this new function that we made. So let's deploy the smart contract. Let's go make sure that it's deployed and it's showing us. And you can see we have pick winner looking orange, looking really nice. All right, so I just want to kind of take a quick pause here and explain what the heck is that? I just want to explain what all of this is, right? Why are these blue? So what does blue mean? Why is that one orange? What does that mean? Okay, and then red. So blue means these are our getters. These are just your public view functions that don't change any data, don't change anything. Rather, they return something. Okay, so these are our getters. And then orange are our setters. That is where you're changing data and mutating data, aka like we're mutating and we're changing the definition of the word players. We're mutating winners because we're adding a player to the winners array. We're taking lottery ID and we're incrementing it by 1. So there's a lot of mutation happening. And then this red over here, it's a legendary weapon. Orange, to me, used to be a legendary weapon in the game Borderlands. So orange is a very special color, but that's not what it means here. Okay, and then red here means it's a payable. There's some payment action, money stuff is happening. Okay, that's as far as I know. When I find out new information, I'll let you know. So the color coding kind of makes it nice. You can look at it visually and know kind of what's happening. All right, now we're going to try this. Okay, so let's go ahead and deploy this smart contract. We've deployed it, but let's enter it with 1 ETH as our, as the owner. And then I'm going to go to another, pick another wallet. And I'm going to put in 1 ETH here, and I'm going to go ahead and enter as well. So now I've entered here. So the pool size now should be 2 ETH. Okay. And okay, actually, let's go and enter with a third person account as well. So let's hit enter. And now we have 3 people in the pool. So that's pretty good. Let's do get players. And look at that. We have 3 players. It's kind of hard to tell, but it's 3 players. All right, so there we go. Let's hit get balance and take a look at that, right? Lottery ID is 0. Balance is 3 ETH. Okay, this is in way, so obviously it's going to be like crazy, right? Because this is the cents in cents, and Ethereum is dollar. So this is going to be a way bigger number. Here is all of the addresses, right? So these are 3 addresses. So here you see the 1 comma and then 2 commas, right? So that means 1 address, 2 addresses, 3 addresses. So 3 players are in, 3 is the ETH, and we will now be picking the winner. So let's go ahead and pick the winner soon. Okay. Now notice that I'm on the notice that I'm on a wallet that is not the owner. Remember, the owner was the first one we used. Okay, the owner was the 0x5b3 one. But I'm not on that. I'm not on the owner. So remember, our smart contract says if you're not the owner, you should not be able to pick the winner. So let's see if we can pick the winner. So I'm going to go down and I'm going to go and try to hit pick winner. And notice right when I clicked pick winner, I actually got an error at the bottom. This error means that I'm not the owner, so it's not allowing me to pick it. Remember, for pick winner, you can see only the owner of contract can pick winner. That's what line 47 is saying. So I'm going to go up at the top and change my wallet address to the owner of this smart contract that was deployed. Now let's go down. Now let's pick winner. And boom, look at that. We see that green tick mark. And that means we were able to pick a winner. Now notice that when I say get players, there are no players. There's 0 players. It's empty. And that makes sense because we, on line 54 of our code, after the lottery winner has been picked, we set the players to be an empty array. If you get the lottery ID, well, look, now it's lottery ID 1. So that's really cool. And when I hit get balance, balance is 0 because there's no more money in the pool. All of the winner has been picked and that winner got all of the ETH. Okay, next up, we're going to make a function that's going to be called get winners. And this way we'll see who won. Get winners will be, we'll do a public view returns here. It's going to be an address of winners. All right, there you go. So now we're just going to return winners. So it's going to be an address, it's going to be an address of arrays. And you could see an array of addresses. I'm sorry, what the heck? And that's what winners is. That's what we're returning. And so you could see on line 59, we're just returning the winners. Okay, when we created that variable earlier. All right, and let's go delete that smart contract. We need to deploy a new smart contract. Well, because we made changes to it, it's a different one than that deployed one. Let's go and go to 0x5. I mean, for you, it's going to be something different, right? But I'm going to go to that account and I'm going to hit deploy. So the smart contract has been deployed. I'm going to pick 1 Ether and I'm going to come to my deployed contracts and I'm going to enter the lottery. And I'll pick another account and I'll also put in 1 Ether and I will enter the lottery. And I'll pick a third account, put 1 Ether, enter the lottery. Once I've entered the lottery, I'll get players. You could see it's 3 players right now. I will say get winners. There's no winners. You could see the array of addresses is empty. And lottery ID is currently 0. Now we're going to go to the owner because only the owner can pick the winner. So I'm going to say pick winner. The winner has been selected. Great. Now let's go ahead and get players. Players are empty because now the lottery is over. Let's check get winners. And look at that. Guess who won? The game is rigged, boys and girls. That's why I told you, don't let the owner hop into the lottery. It's just going to be a massacre, right? The owner, of course, wins because it's rigged. And it's pseudo-random, hell yeah, pseudo-random, right? The owner always wins. That's what happens. So lessons to learn, right? It's a huge conflict of interest. The dude who made the lottery, don't let him jump into the lottery. But yeah, there you go. Owner was picked and look, oh wow, what a coincidence. Check who the owner is and the owner is the same dude that freaking won. Okay, there we go. All right. Yeah, very good. So with that said, you are done essentially with the smart contract part. How does it feel? Do you feel special? Because you should feel very special. This is a huge task that you just completed. And this was awesome. I hope you had as much fun as I had going through it with you and picking up these things and sharing these with you. I think it's just so cool. Like this part of Web3 is pretty cool. And I think, I hope you learn. Anyways, we're now going to take this smart contract that you built and start bringing it into our development environment inside of, whatever you're using, Visual Studio Code or whatever IDE you use to code. We're going to bring it in there. So then our entire app could build off of this. But I like this flow a lot. Build on something like Remix IDE, so you have that iterative instant feedback loop, so you can keep iteratively building. Once you're done building the smart contract, bring that back into your app. Cool. With that said, let's continue. All right, so now what we want to do is I want to take all of this and move it into my coding environment. So I'm going to copy the whole damn thing, okay? Darn thing. Let's copy it. Let's go back to our app, and inside of my app, I'm going to make a new folder at a global level, and I want to call it my backend, aka my blockchain, aka my smart contract part, okay? Because we don't have a real, traditional backend as in Firebase or Supabase or, MongoDB or MySQL or Postgres or whatever. In this case, our backend is going to be the blockchain. That's where we're storing our data and running our app from. So let's go to our command line now, and I'm going to cd into our backend folder. Now, first thing we want to do, all right, so I have this blockchain part. Now, I want to do Truffle init. However, most likely you on your computer might not have it installed, okay? And maybe I might not even have it installed. So first thing we want to do is make sure we install it. So let's go ahead and do npm i-g. Okay, I'll just zoom in here so you could see the command that I'm actually typing. And I know my mouse is blocking this, but it's a -g. Okay, and then we're going to do Truffle. Okay, and then I want you to go ahead and hit enter, and it will start installing it. Okay, there we go. So let's go ahead, install Truffle. All right, it's doing its thing. It's installing all of the dependencies that Truffle comes with. Truffle is very, very helpful in developing and deploying smart contracts. Makes our lives very easy. Okay, let's go and install this. Once it's done installing, I'm going to now say Truffle init. Make sure you're in the backend folder. Very important. Make sure you're in the backend folder. Hit Truffle init. And once you do that, it will go ahead and scaffold an empty project for you. So now you can see that you have contracts, migrations, tests, Truffle, all of that stuff. Now in your migrations, you have no migrations, okay? In your contracts, you have no contracts. So you'll have to start by creating a smart contract. So we'll hit new file. We'll call it lottery.sol. And now we're going to go to our Remix IDE. We're going to grab that contract address that we had gotten. So let's go ahead, select everything, and let's go and copy it. And we're going to bring it and we're going to paste it inside of our VS Code lottery.sol file. So now we have access to it on inside of our project. Let's go to the migrations. We're going to hit new file, and I'm going to say one_deploy.js. And inside of this, what I want to do is I want to say const lottery, and I want to say artifacts that require lottery. Some of this code is going to be new and weird. Just write it and you'll start getting used to it. Okay. But you don't need to worry too much about understanding this because it's not that important. You write it once and then you're done, and you can kind of copy and paste it for all your future projects and you should be good. Okay. And we're going to export the following module. It's going to be a function that's going to take in a deployer. And then we're going to take in whatever we were trying to deploy, and we're going to deploy it and pass in our lottery artifact. All you need to understand about that is that piece of thing that we wrote is going to help us deploy our lottery.smart contract. And the benefit of deploying it is just like the Web 2 deployments, it will deploy it to the Ethereum network, meaning that anybody will be able to actually access it, almost like it's a website or an API that's publicly available. Okay, that's what a smart contract does. Now let's go into our Truffle config file. So I'm going to go and scroll all the way down in my Truffle config file. So it's this file right here. So let's scroll down, and I just want to fix the version. So version right now is 0.8.16. I'm looking at my English little tiny bulldog. Pudgy, please, baby, don't do that. Her name is Pudgy. And we're going to change it to 0.8.15 because that's the version we're using. And that is it for moving it into your Visual Studio Code, into your own, development environment. So at this point, you're done doing that. Next up, we're going to set up the Truffle extension. Let's go. Now we're going to set up our Truffle extension. So the first thing you want to do when you're setting up your Truffle extension is obviously you need to install Truffle from the extensions, okay? Go ahead, type in Truffle, and there you go, Truffle for VS Code. Now, What is Truffle? It is incredibly powerful software built by consensus. And what it allows you to do is, basically integrate your smart contract with Infura in a very, very easy way and deploy to their network. Okay. And it just makes sure smart contract deployment, building of it, incredibly easy. So make sure you're using this for pretty much almost all of your Solidity projects. So at the bottom left, click Truffle and go into that extension. And that error at the bottom, if it pops up for you, just ignore it. It's not important. Now, what you're going to click on is you're going to create a new network. So hover on that, create a new network, and you're going to choose Infura service. And then Infura will pop up and it'll ask you to sign in. Click sign in. And all I want you to do is go ahead and hit authorize at the bottom here. So you make sure that you sign in, and I'll hide myself so you can see that authorize button. Okay, there we go. All right. So let's keep going here. Okay, once you authorize, and that was Kevin and me on the call that you saw on Zoom. Okay, all right. So let's go here. Yep. So now it will say you are signed in. Beautiful. And you can exit out once you've signed in. Now at the top here, it's going to ask you to put your project name. So go ahead and put your project name. We're just going to call it. All right. So I'm going to type in lottery and then just hit enter once you type that in. And then you could choose this project as public. Fantastic. Now at the bottom in the networks, you see it says lottery and it's showing us that it's connected to multiple networks on layer 1 and layer 2. And if you go to your Infura dashboard, you'll also be able to see this project there. Now I'm going to go inside of my contracts. And what I want to do is right click on my lottery.sol and go and choose build contract. So there you go, build contract. So click that. And then once it starts building it for you, just simply wait and go in your VS Code and choose Truffle for VS Code for your output. So you can actually see the output. I'm going to drag this up now and we'll wait for it. And now it says command finished running. So now it's built our smart contract. And next, after we've built it, we're going to deploy it. So then click deploy, go ahead and choose your project. So since we're on the Ropsten one, choose Infura lottery Ropsten, INF_lottery_Ropsten, choose that. That's going to be your deploy destination. Okay. And now it's going to say, hey, enter gas price. Just hit enter. So you can leave it as default. And here you're going to pop in your mnemonic. Okay. So hopefully you've copied your mnemonic from earlier. Remember when you made your wallet? Yeah, that. If you didn't do that, go ahead and create a brand, either find a mnemonic for an existing wallet that you have or create a new wallet and grab that wallet's mnemonic. Okay, this is going to be very important. And then paste that mnemonic here. Once you paste that mnemonic, it's going to ask you to save. And I want you to just save it as, kind of wherever you want to save it. It doesn't really matter. I'm going to save it on my account in desktop. And I'm just going to call it key.env. Okay, it's really just short for Kevin. And then wait for it to deploy. At the bottom, it's loading. Okay, deploying takes a little bit of time. So we're going to keep waiting for the deployment. Boom, there we go. It says deploy succeeded, finished running command. Now grab that contract address that we got from our deployment, copy that. And now you can go over into, we're creating a new folder and we'll call this utils. At the top level, make this folder. Inside of it, we're going to put a new file and it's going to be constants.js. And inside of this file, we can say export const contract and we can say contract address. And then boom, we can paste that contract address, okay, that we copied. There we go. Now our app will have access to this contract address. Now go into your backend, go into your build and grab lottery.json and copy it. Then go in utils and paste that file. So now we just pasted lottery.json. And why we're doing this is because we will need access to our ABI, and this has the entire ABI in there. Okay. Now we're also going to import in our constants file. We're going to import our ABI from lottery.json, and then we're going to export that ABI, as well. So now we're just going to do export contract ABI, and we're just going to say ABI.ABI. That should do the trick. With that said, we're all set up. Our front end now is plugged in and connected to our smart contract and back end. We have access to everything. Now we're going to start creating the lottery from React and start doing the front end stuff. Okay, let's get to it. Now let's go ahead and actually factually connect our backend and front end. Okay, up until now, we kind of pulled that information, a contract address. Now we'll actually like create a lottery helper function that connects it. Let's go into utils. I'll create a new file. We'll call this file lotterycontract.js. And in here, I want to do the following. I want to import my contract address and my contract ABI from the from my constants, okay? Because my constants have access to all of this information. Once I have access to that, I'm going to create my lottery contract, and we'll be doing it in the following way, okay? We'll say, hey, return to me a new Web3 ETH contract, and you're going to take in the contract ABI, and you're going to take in the contract address. And with that said, that is it. So with this thing that we've made, now we'll be able to actually access this in other files and use our lottery contract. And at this point, you could add the export, but we're going to add the export later. And this is just going to be a helper function we'll be able to use throughout our entire app. With that said, let's move on and let's start working on the actual header in our app. All right, now we're going to be building the header, and here's what it will look like. Boom. All right, so this is the header that we're going to be building with the connect wallet button. So I'll put it here as just like a reference point that we can use as we continue building. So let's go ahead and continue building here. All right, so I'm going to pop in and I'm going to say header. Okay, and make sure you are in your index.js file, and we're going to import header from components header. Okay, then just write down header there. Okay, this is a component we've already made for you. Inside of, if you go into the components folder, you'll see header.js. It's pretty much already built, but it does have some to-dos. So it does ask you, there are things that you're going to need to do in there to add functionality. So it says get the connect wallet and address from blah, blah, blah. And then on line 8, it has another to-do, replace the static address. So we've added these to-dos for you to make your life easier. And then we have context as well. So here's our context.js file. So let's go ahead and work inside of our context file. And we're going to keep track of the user's address. We also will want to add functionality for connect wallet so the user could log in. And there's going to be an async function. And we're going to say if the window is undefined, okay, and window Ethereum is undefined, so meaning that, you know, you're not on Metamask or whatever. And then we'll do else, and we'll just say, hey, please install Metamask. Let's add a try catch in between those if statements, and we will try catch it in the following way. So we'll have, we'll console log the error. And then inside of our try, we want to request wallet connection. And so how we do that is we want to do window.ethereum.request method ETH_request accounts. That'll allow us to request wallet connection. Okay, that brings up that little pop-up in MetaMask. And then next up, we want to create a Web3 instance. So let's do Web3 equals new Web3, and we want to pull it from window.ethereum. Let's go ahead and import Web3 from Web3. Great. Let's keep track of a couple of other states here. So we're going to keep track of a Web3 state, and we're going to use that hook right here. And we're going to say, hey, set Web3 to whatever we defined Web3 to be right above on line 19. And then we want to have accounts, and we want to pull all of the accounts from that user's MetaMask, like whatever they connected, whatever accounts they connected. And we're going to set the address to be the 0th account, like the first account that they selected. Okay, now go to lottery contract. And here I'm going to export default, and we're going to export our lottery contract so we have access to it outside of our utils file for lottery contract. And we're going to actually, you know what, rename it. Let's rename it to create lottery contract. That would be a good renaming for this. Let's go ahead and set a state here on line 9, and we're going to set a state for lottery contract. Okay, so we can keep track of everything that's happening because the lottery contract can get updated. So that's why we need to keep track of the state. Now in line 24, I want to say set lottery contract, okay, to create lottery contract. And we're going to pass it web3 that we just got. And then what we want to do is we want to say, hey, window.ethereum.on accounts changed. All right. And we want to run this async function in here. So whenever the accounts change, then I want you to get accounts and set the address to account 0. So if the user changes their account, picks a new account, this will do it. Okay, this will automatically update it without necessarily having to even refresh the page or do anything because it's an on change. It's kind of a listener here. Next up, what we want to do is in our provider, we want to pass this around. So we want to pass connect wallet function that we created around. So our entire app has access to it. And then we want to pass the current address around. So our app has access to it. Okay. So let's go to our header function now. And inside of our header function, you can see it says, hey, to do, get the connect wallet and address from context. So now we're going to go ahead and get that. We're going to finish that to do. So we're going to say connect wallet and then address, and we'll say use app context. Okay, let's fix the address right there. Remove that address. We don't need that. And yeah, on line 18, we want to say, hey, if the user card, so you could see on line 8, we have a to-do that says replace the static address with the currently logged in user. So on line 18, we had a static address. And now what we're saying is, hey, if there is an address, meaning there is a logged in user, then I want you to show the user card with the following address. Otherwise, I want you to show the connect wallet button. Okay, so we're going to say address. We're going to pass it the address. And then for our connect wallet button, we'll say, hey, the connect wallet function should be the connect wallet function that we got from the top. Okay, so that's what we're going to pass in as a connect wallet prop. Okay, great. So we've made fantastic progress on it so far. Let's go ahead and hit refresh. And there we go. Our lottery dApp is showing up. And now let's see if when we hit connect wallet, if it runs. Okay, so it didn't work right now. So let's see what's going on. So let's go to our connect wallet button component in components, and it has a couple of to-dos for us. Okay. So we need to destructure connect wallet because that's what we're passing it. And we need that function to run on click. Okay, so let's go ahead and set that up. So for the button, we're going to give it an on click. And we're simply going to say, hey, run the connect wallet function that we wrote when you do on click. So as soon as you click that, Metamask will then pop up. Okay, so that is how we're connecting that functionality. And here's our user card component that we have made. And we need to destructure the prop, the address prop that we gave it. Okay, so that this has access to the address. And we need to render the user's address in here. So right now we just have some dummy address. Let's remove that dummy address and let's render the user address in there. And we'll just say address, just like that. Okay, great. Now let's go ahead and we'll full screen this so we could see it. Let's hit connect wallet. Boom, look at that, right? MetaMask just opened up. We'll type in our password and let's see if this works. Great, it worked. And there you go, right? You could see welcome. You could see the current user's wallet address. And let's see if it's the actual current user or if it's doing some kind of dummy data thing. And look at that 0xa, right? 0xa, it is the current user. We'll switch users to this 0x31 or whatever. Let's switch to 0x35. Let's refresh, right? Let's connect and look at that, right? It changed the user to 0x35. And so you could see that this app works completely well with this. It's picking up the current logged in user. It's changing the state when we hit login connect wallet. It changes it to the welcome state. It can change the current active user. It is allowing us to bring up MetaMask and unbring it up. And basically it's, authentication at this point of the app is working. So fantastic job if you got to this part. Now we're going to continue and we're going to start adding in the lottery card so you can enter the lottery. Let's go. All right, now let's go and work on the lottery card. First thing I need to do is actually write out the lottery card component, and then you're going to add in all the functionality. We're going to add it in together. So let's go lottery card right here. And if you run this, we get an error which says lottery card is not defined. What we have to do is we have to import lottery card. So that way we actually have access to it. And we're going to import it from components / lottery card. Okay, there you go. We've already made this component for you. Now this component is coming in with dummy data. It's coming in with dummy data. And you can see that we got 10 ETH. We got a winner last, like who won the lottery last. And we can pick our winner. So let's go to context.js. And inside of our context, we want to do the following. All right, so I'm going to say lottery pot, and we're going to say set lottery pot. So I'm going to keep track of the lottery pot state. And we're going to start the state as empty. And then we're also going to keep track of the lottery players. Okay, it's going to be an empty and an array of players. We're going to also keep track of who won last. And yeah, okay. And then we're going to keep track of the lottery ID. Which lottery are we on? Are we on lottery 0, 1, 2, 3, 4, etc.? Let's go ahead and now we're going to write our enter lottery function. And I'm going to say enter lottery. This is going to be async. And we're going to wrap it in a try catch. We're just going to console log the error. Just a good habit to get into. And then in the try, what I want to do, Copilot is telling me everything. I'm going to grab my lottery contract and I'm going to call the enter lottery function that I created on the back end. Okay, it's called enter. Okay, and then we're going to send. And send is going to take in the following information into account. It's going to take in the from address. It's going to take in the value. And so I'm just going to pass it a very small amount of ether as value because that's what I want to put in the pot. Okay, this is the minimum amount that I could put in the pot, and then we're converting it to way because that's what it wants on the back end. All right, now for gas, we're going to just pick 300,000 or whatever that is. Okay, so this is going to be gas in way or gwei. And then we got the gas price here, and gas price is going to be null. Now we want to also export this function. So let's put enter lottery inside of the app context. And now we'll have access to enter lottery in our other files. So let's go to our lottery card. And now we get the data needed from context. Okay, so now we're dynamically getting all of the data. So let's go ahead and import our use app context from context. And we will say use app context, and we're going to destructure the following properties. Enter lottery. Okay. And that's kind of it. That's all we need. And where we have that enter button happening, that's where we want our function to fire off that we just created. So I'm going to say on click, enter lottery. Okay, now let's go ahead and try that. Connect wallet, log in, and then we're going to hit enter. And now we should have entered lottery. And let's see what is happening. We're currently getting some errors. It says cannot read from undefined. So we're going to import create lottery contract from where? Let's see. From our utils. Okay. From / utils / and we're going to say lottery contract. Okay, that's where we're getting it from. Now let's scroll down and let's say 0.1 ether instead of 0.01 ether for our value that we pass. And now let's hit enter. So that way we're just passing in a bit more ether into the pot. Let's hit enter and boom. Okay, that worked. Let's hit confirm. Okay, let's see what happens. So let's take a look at the smart contract here. Okay, our dummy data of 10 ETH is still there, so that's not going to change. But our smart contract looks like it has entered. So our enter function worked. It didn't fail. So that's a great sign. And you can see that we put in 0.1 ROSPEN here, ROPSTEN. Okay. Now, with that part, we're done. Now we're going to make it so we actually update the lottery pot. Let's go ahead and do that. All right, let's go and update our lottery pot now. Okay, so let's go inside of our context. And we're going to update the lottery card dynamically using our contract. Okay, so that way where it says 10 ETH, we need that to update dynamically and not for us to have to manually hard code it and fix it. Okay, so I'm going to make update lottery function here. And this is going to be an async function. And I'm going to say, hey, if the lottery contract exists, okay, then I want you to create a pot. And I want you to go and get me the get pot method. And since we're using Web3, you got to do .call to actually call your method. Okay, and then whatever we get from our pot, we're going to set lottery pot to that. Okay, let's use a useEffect hook. And inside of this useEffect hook, we're going to make lottery contract a dependency. So whenever our lottery contract changes, our app should, our useEffect hook should fire off and our app should dynamically update. And when it does, we should update the lottery. So then we run the update lottery function. All right. Now in our context, we also need to make sure that we export lottery pots or other files have access to it. Lottery pot. Dynamically render the lottery. Okay. So we're going to destructure in lottery card our lottery pot as well. And where it says 10 ETH, we're going to dynamically now write lottery pot there. And it's going to pull from our lottery pot and put that there. Okay, for lottery pot, let's set it to be 0 ETH when it starts. So now you can see it says 0 ETH. Okay, I'm going to make it a string. And then it will dynamically update once we have something in the pool. So let's go ahead and connect wallet. Interesting. Okay, .get pot is not a function. All right, get pot is not a function. So it's, let's see, it's get balance. Okay, there we go. And so we just got the balance and look at that. So on our backend, right, on our smart contract blockchain part, it's get balance. That's what the function is. So now you could see that when I say get balance, I'm getting all of this money in way. And so it is a massive, massive amount. And that's not what we want. So we need to actually convert it back into Ether. So we're going to say web3 utils.fromWay. Okay. And when you do .fromWay, it allows us to convert it back into Ether. That's a really nice thing about that. Okay, so it knows that it's getting way. All right. Now let's go ahead and run this. And boom, that is so clean, right? Now we can see that it's 0.1 ETH that's showing up. And we'll write the word ETH at the end of that. There you go. Now it's at 0.1 ETH. So now our app is dynamically updating. Super cool. Let's now update the lottery ID. Now we are going to update and render the players so they actually show up on screen when they enter. Let's go into index.js and we have a to-do here that's very nicely written for us. And I'm going to say table. All right. And this is a table that we've already made for you. So import table from components table. All right. So yeah. So we're going to get the table. Make sure you've also gotten the, styles. Make sure you have the styles, obviously. And there we go. Look at that. Our table is already showing up at the bottom. Hey, nice. Oh, wait, I'm hiding everything. So I'm going to hide myself. Give me 1 second here. Okay. I'm going to hide myself here real quick so you can kind of see it. So there we go. Right. We got the player showing up now. I'm going to make myself tiny here. Okay, let's go back and let's go inside of our table. And here we can actually we need to map through the players and loop through it. So our to-do is telling us bring in the players data from context. So we need to get the players data. So let's go inside of our context and get access to all of the players. All right, so in update lottery, I'm going to also write a players method. And I'm going to say, hey, set the players to, and let's go talk to our backend or blockchain part. So I'm going to say, go into the lottery contract, go into the methods, grab the get players method and call it. And whatever that returns, let's set that as our player. So it's going to return an array. Let's set that array as our lottery players. Okay, and we can even console log this out so you could see it here. All right, there you go. At the bottom, you could see that we got an array of players. It only had one item in that array, and you could see that we had this guy right there. Okay, and that's the guy that's currently actually logged in, so it is working. All right, now let's go ahead and export lottery players in our provider so that we have access to other files, right? And now let's go to our table.js. And I'm going to basically say inside of the loop here, okay? Or inside of the div there. But first, I'm gonna pull my data from my context. All right, so let's say use app context. And we're going to destructure lottery players. Okay, that's the one that we're destructuring there. And now I'm just going to say, hey, in players row, just show lottery players. Okay, let's do that. We're going to say, hey, if lottery players exist, then I want you to loop through those players and show me those players. Okay, create a table row from each of them and then show them to me. And we're just going to make index the key. For player, we're just going to pass in the player. Okay, that's it. But if they don't exist, then obviously just show me dummy data. Okay, or don't show me anything at all. So we're going to say style of no players, and we'll say no players yet. Now when we run this, you could see that it's actually already dynamically pulling in user information, because you could see this is the guy right there, and you can see 0xa, 1fa, blah, blah, blah. So this is working perfectly. Let's go inside of table row, and you can see that we're destructuring the player and we're truncating that player's address. Okay, that's what's shortening that address, right? So you can see that address is being shortened right there. That's how that's happening. Okay, it's because we have that function truncate that we're calling on it. Okay. Now let's say we change our wallet address and see what happens. Boom. Okay, let's go ahead and hit reject there. Cool. All right, and you could see we have 0.1 ETH, and you could see our user address is still 0xa because that's the player that has actually entered. 0x35 has never entered this DApp, this lottery. Okay, but now let's say that we do enter. Let's see what happens now. So I'm going to hit confirm. Okay, we'll speed this up. I'll just put in high gas prices so I could speed it up. And it looks like it went through. Now we'll refresh the page. And boom, there you go. All of the players are showing up and they are being rendered dynamically. How freaking cool is that? So with that said, we're pretty much done with that part. Just remove the part where it says, 0.015 ETH, and we just hard coded it to 0.1 ETH. So right here, we could hard code it with 0.1 ETH because in this app, the only pool, the only amount you can enter with is 0.1 ETH. So we know guaranteed is 0.1 ETH. So I don't need to pull data dynamically. I can just hard code 0.1 ETH here and be accurate because you can't do more or less than that. Okay. So with that said, we're done with this part. Now we're on to the last and most exciting part, which is we got to pick our winner. So let's go. All right, time to pick the winner. So here we go. Let's go into our lottery card. Here you can see I have my pick winner. Okay. So we need to add functionality for this. Let's go into context.js first. We're going to write our function pick winner that allows us to pick our winner. Let me put a little space after my comment because I'm a professional. And then we're going to say, hey, pick winner function is going to be an async. All right. So here, basically what we're going to do is I'm going to write a simple try catch, and obviously let's console log our error. And then in my try catch, I want to say, I want to define my transaction, and I want to go into my lottery contract and I want to pick the winner. Okay. And I need to send, so to pick the winner, I need to send it the from address. I need to send it the gas and all the other things that it needs. Okay, so we're just gonna pick 300,000 GUI, gas price is gonna be null, and that's it. Okay, pick winner is going to pick randomly. And the reason why it needs the from address is, remember, it's checking for if you are the owner. If you're not the owner, then it won't work. All right. And then what we want to do is, once we get the winner, we want to update the lottery. Okay, so we want to actually, at this point, we want to first update the lottery. Okay, so we want to run our update lottery function, and that way it will automatically update all of the data on our lottery card, you know, the current wallet address, the current users, etc. Let's export this pick winner function so our other files have access to it. Let's go to our lottery card, and here I'm going to get access to this. Okay, so let's go ahead and destructure pick winner, and then we're going to go ahead and do on click pick winner. Okay, there we go. So now we entered our on click, we gave our on click the pick winner. So let's go and now choose pick winner, and we'll soon see what happens. Okay, and let's also update the wallet address for our last winner. So we're gonna, you know, create that function too at some point. Okay, so let's go ahead and set the last winner to be whoever the last winner was. So luckily in our blockchain, we've already made that smart contract. And so I'm going to go to my lottery contract and the methods, and I'm going to extract my get winners. All right, so we're calling our get winners method from our smart contract, which gets us all of the winners. And then from here, what we want to do is we want to extract the last winner. It's going to be an array. So let's go ahead and console log this, and we're going to console log our last winner. So let's go ahead and do that, and let's make it an array. So let's go to on line 12 and let's make it an empty array by default. All right, now let's log in. So now everything got updated right when I logged in. All the users got updated, etc. And let's see if the last winner is showing up. So I'm going to go here. We're going to look at our console, and you can see on the right hand side that right now it says length is 0. Okay. So right now, since we haven't picked a winner, it's just saying 0. But once we pick a winner, it's going to show an array of who won last. Okay. So let's go ahead and do last winner here. Okay. And I'm just going to write last winner there. Okay. And so yeah, let's take a look at it. And now we can see that it's showing us an array of people. Those are players, right? The array that you're seeing with the actual wallet addresses, those are actual players. But the one where you're seeing empty, that's where it's a winner. And it's because nobody has a one yet. So we're going to need to run our one pick winner function first, and then it'll tell us. So let's go ahead to our lottery card. And we're going to dynamically render the last winner, as that note says, because right now it's hard-coded. So let's go and grab our last winner. So we're going to say on line 23, actually, first let's destructure our last winner so we have access to it. We'll go in our context, and we'll make sure we're exporting our last winner. Okay. And then we want to do the following. We want to say, hey, if the last winner is there, then show all of this div and everything that's happening underneath. Okay. So I'm going to say not last winner. Okay, so if last winner does not exist, then I want you to do the following. If it doesn't exist, then I want you to create a div with, we're going to say style.winner. And here we're just going to say no winner yet. And then if it does exist, then I'm going to do the whole winner thing. Okay, cool. So let's see what's happening here. So if there is a winner, then I want you to, if there's no winner, then I want you to say no winner yet. If there is a winner, then I want you to show a address. Okay, show the winner's address. Now here you can see it says no winners yet. That is perfect. Okay, that is what we want when we're doing this right now. Now I'm going to click pick winner. And make sure you're the owner account when you say pick winner. And then I want you to go ahead and hit confirm. Okay. And let's see. We're still waiting. Let's see. Let's speed it up for pick winner. I'm going to put high money into it. Speeding it up. It failed. So let's see why it happened. Because it was not the owner, right? That's why it failed. Now I'm the owner. Now let's pick and let's see what happens. So I'm going to hit confirm here. And then we're going to see if we can speed up the contract addresses. Let's speed them up. Let's put it on high. Perfect. Boom, the winner is picked. Let's go. And now you can see user address is empty because the players are now wiped out because the last lottery is over. Right now we're in a new lottery. So it makes sense why I got wiped out. Now for last winners, it shows us a hard-coded thing. It's saying the pot is 0, so that's good. Okay, lottery number incremented by 1. However, our last winner, okay, it says no winner yet. Sorry, actually it says we have 0x123 blah blah blah. So it's not showing us who the actual last winner was. We need to update that because we have left it hard coded, remember? So we need to go and fix that on line 29. Okay, we're going to take that wallet address and we're going to replace it with the actual winner. So yep, okay. There we go. That's our last winner. We're exporting our last winner as well. Now let's go here. Okay, we have access to our last winner. So all I'm going to do is I'm going to replace all of that and I'm going to say last winner. Okay, and it says address match is not a function. Okay, so since it's an array, we're going to go ahead and say last winner. And I'm going to get the last item from that array. Okay, so all I'm doing here is I'm getting the last item from that array. So let's say I have 10 winners. Well, since I want to get the most recent winner, I'm going to grab the last element out of that array. Okay, and to just kind of visually see it for yourself, it's like if I have David, Kevin, Kazi, and if I want to get the last winner here, well, I want to be able to do, let's say that this is called winners. I want to be able to do winners and get me Kazi. So I want to do winners of 2. Okay. In other words, I want to do winners of dot length, because dot length, and actually I want to do length minus 1, right? Because that'll actually get me the last possible item. So if I do winners dot length, I get 3, I subtract 1, I get 2. This whole thing turns to 2. Winners of 2 is Kazi. Okay, since we start at 0, 1, 2, yeah? Okay. So I'm going to write that. Then let's go ahead and do minus 1. Okay, great. Now let's connect wallet. And there we go. Our last winner, the actual factual person that won, is now showing up. How beautiful is that? Let's click enter to enter the lottery. So now we're basically doing the last final demo run, and let's test if this whole thing works. Okay, let's click enter. All right, I'm going to speed it up, speed it up, speed it up, speed it up. There we go. Okay, so now it looks like I have entered successfully. It did cost me some Ropston to do that because I pooled the money. Let's refresh, and you could see 0.1 ETH is there, and you could see the new user is showing up there at the bottom. Beautiful. Then let's go ahead into our MetaMask. I'm going to switch my account to a different account, and inside of this account, I will hit enter. Okay, let's go ahead and hit confirm. All right, and once I hit confirm here, let's wait for it. We'll speed it up. Okay, let's speed it up, and then we'll hit save. And it looks like I have entered with that one as well. So let's refresh. The pool size, the pot size is 0.2 ETH. Both of the users that are current players are showing up as players. And then we got our last winner showing up as well. So this is amazing so far, you guys. Now we have to switch to the owner of the contract, smart contract address. And then we got to go and pick our winner. Okay, once you are the owner and then you go ahead and pick winner, now we'll just wait for that bad boy to speed up. Okay, let's pick the highest gas price possible. Let's speed it up, speed it up, speed it up, speed it up. And let's see what happens. Boom, look at that, right? All the players got wiped because the lottery is successfully over. The number for the lottery ID at the top incremented automatically. The last winner was updated to whoever won. And always remember, whenever the owner jumps into the lottery, I mean, the chances of the owner winning are massive. Yeah, the game is rigged, so be careful letting the owner jump into the lottery. All right, with that said, I hope that you enjoyed this so very much as I did. Make sure if you did, smash that like button, subscribe to the channel if you haven't already. And with that said, I hope you enjoyed it. Put it on your portfolio, show it off to people, and good luck in your Web3 journey. This is Kazi. I love your beautiful face. And as always, I'll see you in the next video.